Okay, so today we are going to discuss, how to find the largest element in an array. So suppose, say for example, we have an array of numbers and we need to find the largest number in the array. What is the trick behind it? Suppose I have a group of numbers, and how do I make the computer understand which is the largest? Suppose, say for example, these are the numbers. So you can always observe and claim that 25 is the largest number. But the problem is, how do I make the computer understand which is the largest number? So a very simple trick is applied when it comes to finding the largest number in an array. What we do is, whatever is the first element in the array, we assume it to be the largest and store it into a variable, say L. I take a variable L where I am going to find the largest number. And what I'm going to do is, the very first element, because at a time you can make the computer read only one element at a time. So whatever is the first element in the array, what I'm going to do is, I'm going to store it into the variable L. So L will be 4. Now subsequent numbers, of course one at a time, we are going to check whether it is greater than L or not. If it happens to be greater than L, then I'm going to assign it or give it to L. So that's the trick behind finding the largest. So how does it work? Let's see. The first element, I have stored it in L. The next element is what? 12. Now 12 happens to be greater than L, so therefore store it in L. So L contains now 12. That is, it replaces the value 4 with 12. Next comes 15. Is it greater than L? Obviously it is greater, so replace that 12 with 15. 25. 25 is again greater than L, so assign it or replace it with 25. Next comes 17. Is it greater than L? No. Next comes 18. Is it greater? No. So whenever it is not greater, we are doing nothing. We are keeping L safe with that. So ultimately L contains the largest number. So what is the logic behind it? We take the first number and store it into the variable L. Now subsequent numbers, what we are going to do? We are going to check whether it is greater than L or not. If it is greater than L, then I am going to assign or give it to L. So that's the trick behind how to do it. So how do we find the largest in an array? I'm going to show you the logic behind it. So what we do is, we take L as A of 0. Why A of 0? Because A of 0 is the first number in the array. So we take that. Then what we do? We start with a for loop where it ranges from 1 and this will go till less than 10. I'm assuming there are 10 numbers in an array. And what I do, if a number, A of I is each number, of course one number at a time, so A of 1, A of 2, A of 3, like that we are going to get. If any of this number happens to be greater than L, then I'm going to assign this value to L. So L's value will be A of I. So whatever is the value of L will get replaced with A of I. So that's it. This process will be iterated multiple times, and ultimately what will happen is, the largest number will get inside the variable L. So now if I display the value of L outside the loop, you are going to display the largest. Same thing, except for the symbol will be different, that is less than for finding the smallest. There is no issue with that. Now, sometimes I have seen students telling me that, sir, instead of writing A of 0, if I replace this with a 0, and of course I start checking from the first element, that is starting from 0. Now the problem is, you see, it's still going to work. Let's see what happens. Instead of this, what we are going to do is, we are going to do this. We are going to assume L to be 0. Now each element, I am going to check whether it is greater than L or not. If it is greater than L, then I am going to assign it to L. So what happens? 4 is greater than L, then give it to L. Next 12 is greater than L. We are giving it to L. 15, we are giving it to L. 25, we are giving it to L. Next comes 17, but it isn't greater. 18, it isn't greater. So L contains 25. Exactly, we got the largest. However, imagine a situation, you see, the user can input any type of number. It is not necessarily always this. Suppose all the numbers are negative. If all are negative, which is the largest number out here? Obviously, it's -4. So if it is -4, now you see, if you take the value of L to be 0, now what happens? There will be no number which is greater than L. So how can L contain the largest number when all the numbers are negative? So it's not going to work when all the numbers are negative. So please don't take these the value of L to be 0. Some of you make this mistake. Always take the first element in the array as the first number. Of course, we can modify it according to our requirement. Suppose there are people who don't want to use, L equal to A of 0 and then write the entire for loop. They want to initialize the value of L inside the for loop only. So how do I do that? We can easily follow this technique. So what we are going to do is, we are going to start with I equal to 0, and here we are going to put a if statement. If the value of I is 0, then L equal to A of I. And now, if the value of A of I happens to be greater than L, then assign the value of AI to L. Give it to L. So we can do that. So here what happens is, when I is 0, when will I be 0? Only for the first time. That means the first element is being assigned to L. Subsequent numbers, that means it's always better or more efficient if I put else if any of these numbers, that means A of I will be the remaining numbers. This will only work for the first time, because first time when the loop iterates, the value of I is 0. Subsequent number of times the loop executes, the value of I will be 1, 2, 3, 4 and like that. So here, if any of this value is greater than L, then I am going to assign it to L. So this is how it is going to work. Now, there are tricks or techniques by which we use flag variables, to find the largest. We do exactly the same thing. However, the logic is still the same. That is, we store the first number in L, and subsequent numbers, we are going to check whether it is greater than L or not. If it is greater, I am going to give it to L. So let's see the technique or the trick behind using a flag variable to find the largest number. So how do we do that? So I am going to initialize the value of the flag variable. Flag variable is just an indicator variable. You can just take a simple variable, initialize it with 0 in the declaration part. So f is initially 0. So what I am going to do is, I am going to write if f is 0, what am I doing? If f is 0, I am going to store A of I into L. So the value of L will be A of I, and after that what I do is I make f equal to 1. Now look at the trick. What is going to happen? F is initially 0, so when it enters the loop, the value of f is still 0. Now what I'm going to do is, if f is 0, what did I do? I'm storing the value of A of I into L and making the value of f to be 1. That means I'm replacing the value of 0 with 1. So what happens? Next time when the loop iterates, the value of f will no longer remain as 0, it will become 1. So since it is 1, it is never going to execute this if. So my purpose is solved. That is, the first number got stored in L. You see, suppose if it is minus 4, what happens? If f is 0, yes, f will be 0 for the first time. So L will be equal to A of I. So L will be minus 4 and f will become 1. So next time when the loop iterates, the value of I will be 1 and the next number will be minus 12. Now it will no longer come to this if. Why? Because the value of f prior to this iteration became 1. So f will no longer remain as 0. So it will skip this entire if and it will start checking from here. And out here you can do obviously the same thing which you have done in the previous program. That is, if the subsequent number happens to be greater than L, then give it to L. That is, assign the value of A of I to L. We can do that. Similarly, what we can do is we can also use the same trick, however, in a slightly different way. That is, we are going to use a counter for this. So what we are going to do is, we can, write this way. Suppose for I equal to 0, I less than 10, I plus plus. And here, what I'm going to do is, I'm going to begin with a counter. So I begin with a counter, and here what I do is, if C is equal to 1, then L equal to A of I. Now can you tell me or guess what is basically happening over here? You see, what is the function of a counter? To count. So when the loop iterates for the first time, the value of C will be 1. Second time when it iterates, the value of C will be 2. Third time when it iterates, the value of C will be 3. So like that it continues. What is important to us is when the value of C is 1, that means I am iterating for the first time, and A of I, that means is the first number. So when C is 1, that means when I is 0. When will C be 1? When I is 0. Or in other words, when we got the first number, that first number got stored in L. And subsequent numbers, as usual, we are going to use the same technique. A of I greater than L, L is equal to A of I. You see, there is nothing much, not much of a difference between either of this technique. You see, we started with L equal to A of 0, the code which I showed you prior to this. Then we came up with this, and then we came up with this. All these are doing exactly the same thing, that is storing the first number into L, and subsequent numbers we are checking whether it is greater than L or not. If it is greater than L, then I am going to store it in L. Now, why am I showing you so many tricks? You could have just learned a single technique and you could still solve a problem. Yes, you can always do that. Learn a single technique, no doubt regarding it. But there might be situations, or there may be situations where we require to modify, our trick. So I'll give you an example. Say for example, I ask you, suppose I have a group of numbers like this. Suppose I have a group of numbers, say 25, 46, 13, 72, 49, 54 and 36. Suppose I have this group of numbers, and what I am supposed to do is I am supposed to find the largest even number. So if I want to find the largest even number, say for example this first number, I make it 225. How do I do it? Now the problem is, if I am supposed to find the largest even number, I cannot do the trick of storing the first number of the array inside L, because the first number need not be an even number. It may be an odd number and it may be a very big number. So there will be no even number which will be greater than that number. So suppose, say for example, L is 225. So I store the first number. Now subsequent even numbers, none of them will be greater than L. So there will be no issues at all. That is, we can never get any largest even number. L when displayed will display 225. So what do we do? However, if the number is smaller than either of this even number, then we don't have an issue. But we cannot write programs this way. Here we can do it fine. The next even number is obviously greater, we can carry on doing with the same logic. But it is not necessary user is going to think how the coding has been done. He can put any number. So what do we do? So what we are going to do is, instead of using this technique, that is, we are going to store the first number in the array inside L. Instead of doing that, we are going to store the first even number inside L. So while traversing through the array, while going through the array, while traveling through each element in the array, whichever is the first even number, what I am going to do? I am going to store it into L. And subsequent even numbers, we are going to check whether it is greater than L or not. If it is greater, we are going to give it to L. That means the first element, what is it? 25. And 25 is odd, we do nothing about it. Next comes 46, and 46 is even, and this is the first even, so I am going to store it in L. Next comes 13, we'll do nothing about it because it's odd. 72, again it's even, so we are going to check this time whether it is greater than L. Yes, it is greater than L, then give it to L. 49, it's odd. 54, again even, however it is not greater, so we do nothing. 36, it isn't greater, so L contains the largest even number. So how do we do this? Very simple. What I'm going to do is, this entire thing I'm going to do when the value of A of I is even, isn't it? This is the simplest thing what we can do over here. So what did I do? Only when A of I is even, whatever is value of A of I we have, that is A of I is an even number, I am storing it in L. And when F is 0, that means we got the first even number. And subsequent even numbers, this entire block is inside this entire, finding the process of, this entire process of finding the largest is inside this if block, that is the even if block. So we are going to store the first even number inside L and subsequent even numbers. If it is greater than L, then I am going to assign it to L. So this is what we are going to do. Same thing we can also apply out here. So if a of I happens to be an even number, then we can display, we can find the largest even number. That means wherever it is even, C plus plus. So whenever we get an even number, only then the value of C will be increased by 1. And when C is 1, that means we got the first even number, and we can store the value of A of I inside, that means the first even number inside L, and subsequent even numbers, if it is greater than L, then assign the value of A of I to L. So this process can be iterated this way. So this is the easiest trick of finding a type of, finding the largest number. That is, you may get questions regarding, finding the largest even number or smallest odd number or finding the largest prime number. So all this will be using either of these two techniques. It is easier to do it this way. And moreover, you sometimes get questions that, you are supposed to find the largest even number, if any. What does it mean? That means the user not necessarily is going to input any even number. Because user is a user and user can input, any kind of number. So you can expect a user not to input any even number. So in that case, what is the largest even number you are going to display? So you're not going to display. In that case, you can give a message, no even number found. So how do we do that? We can simply put a if before printing it. If the value of C happens to be greater than 0, what does it mean? That means we have an even number. If we have an even number, that means there is always a possibility of having the largest even number. So C will be greater than 0 when? Only when the value of A of I is even. Only then C is getting incremented, because C is initialized with 0. So C will be increasing, whether it will get incremented by 1 or get incremented by 2. Whenever we get an even number, the value of C is increasing by 1. So at least it will not be 0. So if C happens to be greater than 0, that means we have an even number. And if there is an even number, there is always the largest even number. So in that case, you can display the largest even number. Otherwise, you can display a message that there is no even number at all. You can print this. Similarly, out here, even with flag variables, we can do or apply the same trick. That is, if the value of f is 1, only then we can declare that we have even numbers, and if there are even numbers, we will always have the largest even number. So if f is 1, you can display largest even number is L. Otherwise, there is no even number. So only when f is 1, what I mean to say is only when the value of f is 1, we can display the largest even number. Otherwise, we are going to display there are no even numbers. So that's the trick for finding the largest or smallest number, or a type of largest or a type of smallest number. That's it. I believe you understood this. Thank you.